Good afternoon, everyone. My name is Brian Yin. I'm in grade 9 and I'm a student at Iroquois Ridge High School. And my Base of Science Fair project is about emergency fall detection to protect our seniors. Starting off, overall system design and prototype. So essentially, my project is a wearable device that you could put on your head. And basically, what it does is that whenever a biker is wearing this helmet, if they do fall over and go unconscious and fall victim to some injury, well, the helmet can detect this and is able to contact EMS or emergency contact very fast. Now, the project contains mainly four big parts on the wearable device. There's the knock sensor, the GPS sensor, the Wi-Fi sensor, and the Arduino Uno. What the knock sensor does is that it detects whether there's a big change in vibration, meaning that whenever you're biking, there's always like tiny vibrations, but all of a sudden, if you have a big vibration and you fall over, it's going to be able to detect that and it's going to send a message to the Arduino Uno. The GPS sensor is very basic. It detects where you are, and the Wi-Fi sensor is able to connect to your phone's hotspot so that it's able to send messages and alert notifications to ThinkSpeak.com. Now, ThinkSpeak.com is a place that stores the data, and it puts it into two places: the data analysis table, and it also uses it to contact EMS and emergency contact. So basically, it's a very simple diagram, right? So if let's say that I'm on a bike one day going down a trail, and all of a sudden if I do fall over and hit my head and I start bleeding and I go unconscious, well, what happens is that the helmet detects this by all of a sudden I stop moving because of a big vibration. So then it sends a message to ThinkSpeak.com, which can then contact my mother or father or emergency contact members. And if they don't respond, it's going to call EMS. And it also sends it to the data analysis table, and then this data analysis table, if they do call EMS, they can tell them, hey, what's my name, what my phone number is, what my location is, what time I fell over, etc. Now, the purpose of this project is to investigate the current technological capabilities to determine whether we can design a wearable device to detect falls and to send real-time notifications. I have planned to have a multi-year project with an initial focus on data collection and data distribution. And on future projects, I plan to mainly focus on data analysis and pattern recognition. Now, the primary potential application of the design is to protect our seniors, because seniors are the most common demographic that fall when riding bikes. My hypothesis is that the current technology and tools, especially the sensor capabilities, are able to support this design. How often do falls happen to our seniors? According to Statistics Canada, falls are the most common cause of injury amongst older Canadians. Every year, it is estimated that 1 in 3 seniors aged 65 years or older are likely to fall at least once. How to better protect seniors from fall? First of all, prevention is very important. Second of all, quicker response is also extremely important. So the basis of this project is that we need to automate fall detections in a timely manner. We have to automate information collection, for example, time and location and distribution. And we also have to automate data analysis to identify patterns in order to support future prevention. And hardware selection. So when I was selecting hardware for this project, there were many different stages. Starting off with the first stage, I had to choose a small size computer that fits for a wearable purpose. Obviously, I can't put a very big computer on top of a bicycle helmet, so I had to go something smaller. So I had the choice between an Arduino Uno and a Nano. And since I already have prior experience and I also own an Uno, I decided to opt for the Uno. And the Nano is better. The Nano is better than the Uno because it's smaller and more compact, so it would work better when putting it on a bicycle helmet. But for this year, I chose to use the Uno as I have more experience with it. Next year and in future projects, I plan to use Arduino Nano in order to make the whole design more compact. Next, I had to choose a knock detection sensor. So I had two options, a vibration sensor and a knock sensor. Now, the problem with the vibration sensor is that it's too sensitive for this purpose. Like light movements such as shaking head or hands can cause the sensor to be triggered. And we don't want that because we want only like the big parts, the stuff. Like all of a sudden you fall over, that's what wants to be detected. So for the knock sensor, that's better because the knock sensor is not as sensitive and it only detects like certain like shakes of your head. So if you like run over a rock on the bike, it's gonna detect that. And if you fall over, it's gonna detect that. But like really light movement, it's not gonna detect that, which is great for our project. Third of all, we had to choose an internet connection module, and I had two options, a GSM shield and a Wi-Fi module. Now, I will say this, the GSM shield is more expensive and requires a SIM card, but it is better. Why, you say? Because the GSM shield can directly send text messages, so you can program it to say, hey, if I've fallen over, directly send a message to my emergency contact members to basically call EMS, and if they don't respond, call EMS directly. So it reduces a step in the process which contacts EMS faster. But for this year, I chose to use the Wi-Fi module as it is less expensive, and it's okay to keep the step that I have right now. Fourth and last, we have the location sensor, which is to be added, meaning that I do have it, but I have not added it to the whole prototype yet because of some malfunctions with the coding. And I chose the BN220 as a GPS sensor to detect the longitude and latitude location where this device resides. The prototype setup. So as you can see in the top left corner, we have the whole setup. We have the breadboard, the sensors, the Arduino board, and the battery. So the battery is on the very bottom. The battery is connected to the Arduino, which is powering it to be turned on constantly. And the two sensors are constantly sending messages in between the Arduino board and the sensor. So for example, the knock sensor is always sensing vibrations like big vibrations, and if it does sense a big vibration, it sends it to our Arduino, and the Arduino can then send it over the Wi-Fi sensor to like your phone, and your phone uploads it on ThinkSpeak, etc. And on the bottom left corner, we have how it's put onto the helmet. I know it doesn't look very consumer friendly, but this is pretty good so far. We can see that we have the board there, the battery, and the breadboard. So basically everything is interconnected together, and the battery is connected to the top of the battery, and everything else is on the top of the helmet, and the sensors are on like the back, which means that if you do fall over right now wearing my prototype, don't fall on the back of your head or the top. But if you do fall on the side of your head, the prototype successfully detects this and can tell ThinkSpeak that, hey, this person has fallen over, notify EMS, etc. On the top right, we have my code, and we also have the table at the top that has been shown before. ThinkSpeak Setup. Essentially, this is the ThinkSpeak Setup. On the left side, we have the channel settings. In the middle, we have the data collection. On the right side, we have the data sent from the Arduino. Testing results summary. Fall detection. The knock sensor is able to detect hard impact, and this was tested by knocking the sensor on the tabletop and by attaching the device to a bicycle helmet and dropping the helmet on the ground. Generally, the falling detection sensor does work, and it's very successful. Data communication. The Wi-Fi sensor sometimes needs longer to connect, like 20 seconds or so, but it is able to send data over the Wi-Fi or hotspot very successfully, so overall very good. Data collection. ThinkSpeak website runs very fast and collect data successfully. Issues identified and will be investigated later. When increasing data collection and publishing frequency on the Arduino, not all data is received on ThinkSpeak. There seems to be some data loss in the middle, and further investigation will be needed conducted to determine whether the data has not left the Arduino, or whether ThinkSpeak has failed to accept large amounts of data. So it could be either of the two possibilities. But generally, overall, the prototype meets my expectations, and I plan the following improvements in my next version: switching to Arduino Nano to make the device smaller, researching another Wi-Fi module that can initialize faster, and last but not least, investigating the data loss issue. Therefore, thank you for listening to my presentation, and I hope you learned something. I hope you have a great day. Thank you.